we come to what I think may have been one of my worst mistakes in my career. I shudder to think of how many billions of dollars of something of lost productivity result from that one error.
Gavin King, the creator of Hibernate and key contributor to enterprise Java specifications, shares his Hibernate creation story and how he's currently modernizing Java persistence.
What exactly the problems that you saw back then that led you to creating Hibernate?
My career really started out of my frustrations with the Java EE platform. Hibernate started as a result of a kind of an argument I had with my boss at the time who wanted us to use entity beans. I argued that entity beans just didn't work very well. Many people carry around the belief that specifications designed by committees are doomed to fail or be bad in some way. I actually hold absolutely the opposite view. For my career, the things I'm proudest of is the specifications work we've done within JCP and now at Jakarta.
Explain a little bit why there are such love and hate relationship with ORM.
In the past, Hibernate picked a way of doing things which involved more magic than some people probably want. People have been sold in this notion that persistence can be transparent. My goal has always been to give people powerful primitives so that they can implement whatever sorts of architectural decisions they wish to implement. The whole discourse around design patterns and architectural patterns lacks foundation in logic and math. It lacks empirical foundation. Architecture is something that has to emerge naturally from the code. If they don't make the code better and more elegant and more flexible, then you should not be doing it.
All right, so welcome to the Tech Lead Journal podcast, Gavin. It's my pleasure actually to have you here. So I had Sane maybe a couple of weeks back, right? So I'm very happy to have another, so-called Hibernate creator to be in this show. And I must say, when I started my career, Java Persistence with Hibernate is like my go-to book. Especially 20 years ago, I just started my career, learning about Hibernate and all of that. And thanks for writing the book, and it's my pleasure to have you in the show.
Thanks for having me here, and thanks for liking the book, and that's great to hear.
So Gavin, maybe people know a lot you as the creator of Hibernate, but maybe let's start by maybe sharing some stories about yourself, any kind of career turning points or highlights that you probably think we can learn from you.
I don't know how much there is to learn from me, but I guess I can give you a rundown of I started my career by dropping out of a PhD and going to work for a bubble tech, the original tech bubble company, startup company, and because I was just very interested in this new world of the internet, right, and the World Wide Web, which was, I was reading Wired magazine, and I didn't have a background in computing, I have a background in mathematics. And I started working with Smalltalk a little bit, and then very quickly Java came through like this wave which took over the industry at the time. And so I started working with Java. I was working at a consulting firm in Australia who were doing IBM WebSphere consulting, so building applications on top of using WebSphere. And I guess my career really started out of my frustrations with the Java EE platform as it existed at that time. And so Hibernate started, in one sense, as a result of a kind of an argument, a debate, let's say, I had with my boss at the time who wanted us to use entity beans and the standards because, he argued, in a sense quite rightly, that there is value in standards, there's a value of having a standard way of doing things so that everybody knows how to do things in the same way. And I argued that entity beans just didn't work very well, and that no matter what the value of a standard is, if the thing doesn't actually work, then you shouldn't use it. And so I was very interested in open source, which was kind of I don't want to say it was a new thing, but it was something that was new to me. The idea of the whole question of how open source related to the commercial world of building software for money was a very interesting, to me, just a very intellectually interesting question, right? How do you, what is the best way to produce software, this thing which has a 0 unit cost of production, but is on the other hand very expensive to produce? What is the best business model for accommodating those economic realities? And so I was interested to start an open source project, and so that's how Hibernate began, I just started writing some code for persistence and put it out there. And in those days, that was a way that it was quite easy to get attention. I think it's probably harder to get attention just from that today. And I think that open source projects today that become successful are a lot more of them have some sort of corporate backing. But at that time it was possible, and so there was a lot of that going on. Pretty soon, like a year and a half, 2 years later, I was absolutely overwhelmed by the amount of work that was involved in supporting this open source project. And so this is critical to understand that, an open source project does require some sort of business model behind it, or you're just going to be overwhelmed by the work it takes to support it. So I was looking for a way, I got fired from my job for spending too much time on this, I was out of work for a while. That was quite precarious, actually. But I had this thing there that seemed to be going places, right? And I was actually in Boston for a speaking event. I forget what it was, but and then there's a couple of guys from this tiny little company that was barely even a company at that point called JBoss from Atlanta, Georgia. Flew up. Well, actually, Bill lived in the area, but Ben flew up and to talk to me, and they were like, would you be interested in, coming and joining JBoss? And I was like, yeah, hell yeah, absolutely, I'm interested. That was exactly what I was hoping you were going to ask me, and so I moved to Atlanta from Australia, and then began the 2 or 3 most intense years of my life in some ways, of just flying around and, talking to people about Hibernate and it was crazy. It's amazing to think of all the stuff that happened in what was really such a short period of time. At one point, and I think a very important turning point was that Hibernate was not the only game in town at the time. There was JDO, for example, which was a specification that these object database vendors had. Yeah, those kind of came later. Yeah. No, at the time, the biggest kind of sort of contrary, other option that people were pushing was the JDO specification, which was already an existing specification. It had certain features that meant that I really didn't like it, but there was a perception that we needed to adopt some sort of specification. JBoss was implementing Jakarta, Java EE, and there was a perception that we should be somehow involved in the specifications. What happened eventually was that Mike Fleury and I one day got on a phone call with the EGB3 group, and I proposed that, hey guys, why don't we just drop this whole entity beans thing, do something else, which is more like the direction of Hibernate. After that, the TopLink guys got involved, and then JPA was born, the Java Persistence API. Now, that was, an incredibly politically fraught process. It's, huge credit to Linda McCall for actually living through and having to, fight through all the stuff that got thrown at the JPA. I learned so much from that, and in particular, I learned a lesson which I think that many people, a huge number of people back in those days, and I think still these days, carry around a belief that specifications, and especially specifications designed by committees, are doomed to fail or be bad in some way. I actually hold absolutely the opposite view from my experience with that, working on some of these specifications. I think that specifications force you to really think through the semantics of things you're doing, iron out the little corner cases, and so I have a very different attitude towards specifications than I think most of my colleagues. And I learned that from Linda, from watching Linda work, and so for me, for my career, the things I'm proudest of is the specifications work we've done within the JCP and now at Jakarta. After that, I was concerned about the question of how these kind of more, what were considered sort of more back-end technologies, EJB, JPA, integrated with the Java EE web layer, the servlets, etc., JSF. And so, there was no good tie in there. You kind of were forced to introduce a sort of a layering, which was unnatural. And the, EGB3 had a kind of a dependency injection approach, which at the time was a super popular thing, but it wasn't really well integrated with the web layer. You had JSF had its own sort of approach, and so I proposed this JSR, the specification request called, which was titled originally Web Beans, to kind of integrate the two sides of the, Java EE programming model at the time, after EGB3. And that eventually evolved into what's now called CDI, which is kind of a central sort of glue that, now today holds the Jakarta EE platform together in some sense. And that was, again, a very interesting political process. Some stage, anyway, that was interesting. After that, I had got a bit frustrated with all the politics, which is something I think a lot of people go through. And I was also kind of frustrated with the Java language as it was at the time. I was very frustrated. I felt that the things we were doing as builders of frameworks and libraries, we were always stuck in this straitjacket of what was possible in the language. Even today, there are just things that are missing from Java that would make my life as an API or library designer, like the ability to be able to refer in a type-safe way to a method, a function, right? The lack of method references is, to my mind, just 2025. The language has been around for decades. Is crazy, right? Java has improved a lot. At that time, we didn't even have higher order functions, etc. So I proposed to my boss that we do a language that would enable us to do more in our platform and in the libraries and frameworks we were building, and so that's how Salon started. Salon was something I at one stage after the dust all settled, I sat down and I realized I'd spent 10 years of my life on that, right? I mean, in a sense, we did a lot of, really great technical things. The type system of the language is, I will defend that that is the right type system for a language with subtype and parametric polymorphism and normal typing. Like that is the correct type system, and there are things which just work out so much more elegantly with that type system. Sadly, in terms of our commercial perspective, we had a user community, but it just never, Red Hat, in part because Red Hat didn't really know what to do with it in terms of promoting it. In part, I'm sure because of mistakes, we made. It wasn't so easy to just kind of start using it in a language, in a project which is already in Java. Anyway, it wasn't a success, and eventually the project ended, and that was a really a thing which, sent me, really into a period of, I don't know, I wouldn't say depression because I had my family, I had my salsa, I had, lots of things going on, but in terms of career-wise, I was very unmotivated. And, I would say that, so that's important to acknowledge that, a career goes through, ups and downs, these incredibly intense periods, and then periods where just, things, you just feel like, well, what do I do next? I don't have anything. And eventually, when Quarkus came along and we were kind of looking around and realized that persistence was still, I sat down one day and I was like, oh, they want to use Hibernate. I'm like, 15 years and I'm like, is this still something that's, I'm like, is this still something that's relevant and important today? And, so I went and pulled the data set they have for Stack Overflow and did some analysis on that and, looked at some other, and it turns out, it turns out this is still what everybody's still all using. And we've kind of had it a bit in maintenance mode, right? And so, I don't want to say that this all happened all at once, but so I kind of came back and started asking the question of, well, if we were designing this today, what would we do different? How can we go beyond what were the limitations. And so somehow I got dragged back into doing Hibernate again, something I promised that I wasn't going to let happen. I don't know. It turns out that there was so much still to do, and the persistence. Nobody talks about persistence, but it's like something that is so central to really what most enterprise programs do. That it's something we should actually probably talk about more, right?
Yeah.
So that brings me here, and that's what I've been working on recently.
Wow, thank you so much for sharing. Almost kind of like a full picture of your career, I would say. There are ups and downs. I think one thing that really stood out for me is your persistence. I mean, not talking about persistence, but persistence in pursuing the idealism, right? So, like when you fought with your boss, trying to pursue how to create standards, specifications, making the open source successful, and then creating a new language because you think there will be a better way of creating new language. And then, coming back to, working on the Jakarta EE stuff, I think definitely we as community can thank you for your contributions towards all these great inventions, right? So maybe if I can just try to pick some parts of what you just shared, right? Let's start with Hibernate, right? So you were saying back then EJBs, right? My experience with EJBs when I studied in university, maybe it's EJB2 something. It was quite horrible, in fact. But what I wanted to ask you is like, what exactly the problems that you saw back then that led you to creating Hibernate? Like, because Hibernate is like a new paradigm altogether. The way it works.
Say that, but
yeah, maybe.
Finish the question.
Yeah, because to me back then it was like totally new paradigm. It's a Pojo thing, right? And then you have some, annotations and all that. It feels different for me. But maybe tell us a little bit more the story. What frustrated you the most, and what led you to creating Hibernate?
It's a good question. So it was unclear, I would say, at the time whether, and I'm still unclear on this, whether entity beings had ever, okay, first of all, let me take a step back. I wasn't around. I was like, the very beginning of my career, I was not involved at all in the creation of any of the Java platform up until EJB3. I don't really know what happened, right? And so it's hard for me to come up with explanations for what went wrong. But my speculation has always been that Java was new. Nobody actually knew how to write Java effectively at the time. And I speculate or infer that the people who were writing the specifications for the early versions of Java EE were in fact not Java developers. Because that was the next generation of people who were actually Java developers, right? And so they had inherited some thinking about the ways to do things, which kind of came from C++ and kind of came from Corba and the work on that. And the web was new, and the whole question of how you what the architecture for a program which makes data available on the web. I mean, this was something which was new, and there weren't answers, and so it's normal that you take some time to evolve a meaningful, the right solution. I think what went wrong was that somehow some people's experiments kind of got pushed suddenly, all of a sudden, on, I don't know, hundreds of thousands of developers before going through a process of maturation and, okay, did that work? Oh, no, no, well, we better change it like this. And so it was kind of a victim of its own success. And suddenly you had a bunch of angry people because they'd be told that this was the way, this is what they had to do, which is probably never the intention of the people developing. I'm quite certain that the people who are developing this platform, you used to hear, oh, vendors are terrible. They do, they're always in their own interest. No, I'm quite certain. I know some of the, I've met some of these people. I'm sure that their intentions were to produce something great that made it easy as possible to build these systems. But I think that just nobody knew the right way to do things at that time. And so I think that's what went wrong. Specifically in the case of entity beings, which is always the worst part of it, I'm not even clear that they were originally intended for object relational mapping. Okay, I don't know the answer to that. It's unclear. I've heard Some people say no, I've heard some people say yes. But certainly they were interpreted as that, things with an identity, or at least people were looking, people obviously were looking for, okay, we've got this platform, how do you do, how am I supposed to interact with a database? And so, that was an obvious construct to map to the data. Or we have these things with an identity, they're sort of persistent, and so we'll try to map them to the issue was that building an object relational mapping solution is an enormous undertaking, and that just wasn't there, nobody had a good enough implementation. A second problem was this issue of how, I'm trying to avoid all sorts of words I hate, like heavyweight, which I think is a meaningless term. In EJB, there was an extremely intrusive programming model and quite verbose. And this was in a time when Java, the language, didn't have the kind of tooling we have today. The language itself was more verbose. We certainly didn't have coding assistance. And so the amount of just typing it took to create a simple piece of functionality was out of control. Sometimes people fail to recognize how far we've come, right? From WebSphere in those days to, Quarkus today. I mean, just the fact of, how you spent all day restarting the server and, to see your changes. I mean, it was awful. Yeah. Nowadays with Quarkus, you just make a change and there it is, refresh, there it is, right? It's crazy. So I would say, it's a combination of people were trying to do things before really understanding the problem well enough, and just because of the incredible amount of energy and attention and in Java at the time, stuff just got adopted wholesale before it had been, too fast, right? Is what I would say happened. But and this is what I think people should give more credit. We fixed it, right? Like the Java community process responded to that. They went, guys like, JBoss, annoying JBoss people who, people didn't necessarily like us very much, right? We came along and said, no, we should do this and this. Who the hell are you? You're like 4 guys and a dog in Atlanta, right? But they responded to that, right? These enormous companies, they went, all right, okay, let's do what these guys are telling us we should do. I mean, do you realize how, that is something they deserve massive credit for. And so the truth is that the community process that Sun had set up was successful. It responded to the objections, it improved the platform, and the platform actually kept improving. And what we have today is, is it perfect? No, it's not perfect. But in fact, I think is a sad thing is that the platform went through several years of not evolving very fast. And I am hopeful that there's a fair amount of energy coming back into it right now, and coming back into, certainly on the persistent side, things are moving very fast right now. And so, I know I'm said too much about specifications and about, but I think that some of the narrative I hear, I think is unfair.
Thanks for sharing the perspective from you. Even though that's not true, right, 100%, but at least we got a glimpse how difficult it is to actually evolve a language that is being used by a lot of people, especially enterprise, right? Mm-hmm. And there's so many vendors, backing it as well, right? So definitely to make a change is not an easy thing. Mm. Personally, myself, maybe I haven't used Java a lot in the last, maybe 10 years, let's put it that way. And I saw your demo just recently as well. I think the amount of changes, it seems pretty intensive. Like a lot of new stuff being introduced to the language, I think it's pretty exciting if, let's say, people are still working on the new Java version, right?
Yeah, I think there are people, sometimes I see comments from people talking about, criticizing Java, and I can just see that they are thinking of a version of Java which existed 10 years ago, and it's not the reality of the current technology, of what's there today.
Right. So Hibernate definitely is like one of your biggest achievement, I would say, right, in your career. So obviously it's very hard to kind of like summarize the key success factors to the project. But now we can see like millions of downloads, and maybe people even like pulling it out of a framework without actually knowing Hibernate is there. And there are many contributors as well. I think Sane told me the other day there are like thousands of contributors to the project. Maybe as a creator yourself first, like how do you feel about it? And what do you think, if you can pick maybe, I don't know, top 3, top 5 key things that make Hibernate really successful?
I mean, first of all, I mean, it's wonderful. I mean, I'm so happy to have, got lucky enough to have been able to do something that was so, kind of so significant in enough people's lives. I think that's the most you can hope to get out of a career is to make things better for a significant number of people. Yeah, I actually, Sunny would know how many contributors there are because he recently led the process of relicensing Hibernate and getting all the contributors sign off and permission to switch to the Apache license. So yeah, I mean, there've been a lot of people worked on it over the years. So why was it successful? I mean, again, I think it was successful because, first of all, because of solving a problem that is absolutely ubiquitous. Persistence, as I said, is something we barely talk about, but it is there as an incredibly important problem in, essentially all the programs people write. It is underserved. People don't pay enough attention to it. And if you can find a niche like that and make something which addresses this extremely common unaddressed need, then it can become very successful. Obviously, the fact that it was open source, especially at that time, was enormously significant. Obviously, TopLink could not. TopLink, which is took a relatively similar approach, didn't have the potential to blow up the way Hibernate did because of the commercial nature of it at that time. So that was very important. As I kind of alluded to earlier, I think that at that particular point in time, it was very easy for a little open source project run by a couple of guys to get attention. And I am very sad that I think, at least in the Java world, that we've lost some of that. And that now we expect for everything to come, all nicely packaged up from a major vendor. And guys, I mean, you don't need to be spoon-fed everything, right? It can be good to try out something you find on the internet, right? And see if it works. I'm a little concerned that now we have, and I mean, it's great in some sense that we have such a high expectation of platform integration that you just pull Quarkus and then everything's there for you, right? I mean, that's great, but I almost feel like we've moved away from this, thing we had where somebody could put something out and people would try it out and then people would get it and, have their flame wars on the server-side.com about it, and it would be this thing that everyone was talking about. Perhaps that just represents the fact that there's less energy in Java these days. Perhaps, that it is still the case in, if we would, for people doing AI stuff, that the world really still is like that. I'm not clear on that. I don't think it is, but not in quite the same way. Yeah, I think that was an important factor, that the world at the time was a little more. And here's what I want to say, where I'm going with that. I think that the world of blogs and news sites was a better world than the world of Twitter and LinkedIn, right? For people trying to build interesting things, right?
Why do you think that's the case?
It was the fact that you could publish news on the server-side.com, that they would go, great, they would publish anything, right? And the whole, not the whole community, but like a significant chunk of the community would see that and respond to it. Twitter is like this fragmented thing where people don't interact because, what happens on social media? Yeah, we used to have flame wars, but social media flame wars in this tiny little, messages are way more toxic. And so people don't interact. People don't get into any sort of debate of substance on social media today. People post stuff on LinkedIn. It's crazy to say it, but LinkedIn is kind of more interesting than Twitter these days, it feels like. And yeah, it's just the nature of, where publications have to fit on the screen of that thing. There's just less content, there's less sophisticated ideas being communicated, and somehow we have to get back to mean, there's no going back to blogs, I guess, but we have to open up a space where people can communicate ideas that don't fit in on this. I don't know how that's going to work, right? But it'll happen eventually.
Right. I think some of the alternatives these days are like Reddit, Hacker News, those kind of stuff. But obviously, sometimes it's like the social media effect as well. If it doesn't get picked up by somebody and doesn't get commented as well, I guess it will be drowned against all the other posts. So yeah, definitely thanks for sharing, the key success factors. And I think it works as well, right? Hibernate works compared to, I guess that's the key success factor as well, right? And it gets adopted by other frameworks as well. So I think, and the vendors, the enterprise Java enterprise server or something like that, right?
Right, and once again, right, it was important. People may not realize it, and some people thought it wasn't important. Some people thought we shouldn't do it, right? It was important that we wrote the JPA spec, and that then Hibernate was implementing a specification that was, the specification is this public document that says, hey, those of us who know something about this topic, TopLink and and JBoss and Sun and IBM, we've come together and we come to agreement that this is the right way to do persistence in Java, and here we have documented and laid out what it has to do, right? There is huge value in that, and it was important to Hibernate, to the success of Hibernate, I believe, that we did that, we took that step. Otherwise, I'm not quite sure what would have happened. But, you can say that, okay, Spring have always been hostile to going down that path and they become successful. Anyway, I don't know how much I want to go. Let's not go there right now. But to me, I think that, particularly given that Hibernate at the time was not the only game in town, that it was very important to have been part of it, to have had this specification where we were not the only implementer, that there was TopLink, that there was other things implementing it. Right? I think that was also important.
Right. I think this is also a good segue to go to your work at the standards, specifications, and all that, right? I think for many people, right, we are not involved in this kind of process, right? So maybe let's try to demystify what actually happened behind the scenes when people are putting JSR, putting something to the standards. And you were mentioning political a few times. I guess maybe if you can share a little bit, what's the process like? How difficult it is to introduce a change to a language that is kind of like widely used, a lot of enterprise usage, and it has to be backward compatible, right? I think those kind of main things about Java.
Sure. So I can't talk about the language. I've never been involved in the Java SE side of things. Okay? I can say sort of a little bit how it used to work with the EE specs was that, you submitted a JSR, and one of the big things was to have a specification request and then convince enough of the members of the executive committee, hey, this is something that should, give us a chance to work on this, right? Then you need to form a group of people who are actually going to support and actually, give meaningful feedback. You don't want to just sit down by yourself and write a spec and then say, hey, vote on this, right? You want to get, you absolutely have to get meaningful feedback and suggestions from, the other people working in that space, because the simple fact of the matter is, often I know what the right answer should be. Not always. Very often someone would come on me like, oh yeah, shit, I didn't think of that. Yeah, we should do that instead. Great. Like, having a way to gather feedback from, especially feedback from other groups, which maybe, we may be vicious competitors in other scenarios, but you want to get together, ideas. I think people imagine that the process of writing a spec involves a lot more horse trading than it actually does. Obviously, there is a lot of negotiation, but the kind of negotiation that, at least ideally, is more, involves a lot more, okay, let's all sit down and think about what is the best solution that addresses everyone's substantive concerns. I have not, at least in my experience, I have not seen this dynamic that people, I believe, assume, and that I used to hear people from outside saying that's how it works. Oh, such and such is trying to standardize their technology, right? And they're just trying to put a rubber stamp on. I have never particularly seen that dynamic. Yes, people will come and they will have a product now of an implementation, and obviously, that does what they thought was the best, was the right way to solve the problem, and they'll say, yeah, we should do something like this, okay? But I at least the people, most of the people who are actually get involved in this sort of work are people who are, extremely open-minded, or extremely committed to finding the technically best, option. And so in the best case where people are, and also it takes a particular personality type, right? It takes the sort of personality which is the sort of person who is not going to sort of get defensive of the first solution they came up with. For me, working on these things, I have to, it's something I like. See, they're always telling myself, okay, don't, give this, it's fair, give this, what this person's saying, it's fair hearing. Switch into this mode where you take this idea seriously and take it and see how far it gets, right? And that's not to say I'll be like, oh yeah, that's a great idea to every proposal. Absolutely not. In fact, I'm more likely to be okay about this, right? And this, and this. Okay, but it has to go through that process, right, as well. But that doesn't mean that I'm not there telling myself, okay, but what are the pluses of this? Even if I don't like it, right? What does it have? What is there in there that, even if this is not what we go with, that we need to somehow recover that good aspect of it, right? And so that takes a particular sort of mental discipline. I think not everybody has or wants to have or whatever. I don't know. It's a different thing to sitting down and writing code.
Yeah, I guess it involves a lot of people, right? Maybe a lot of backers as well.
Typically not so much. Typically, the specifications I've worked on had a relatively small number of active contributors. In fact, that's probably what works best. It's when you have 3 or 4 people with 2 or 3 suggestions for how to do something, that probably works better than if you have 20 people with too many good ideas, right?
So I think definitely, right, the persistence of you pushing into the specifications, I think we all can thank you for that, because back then when I was starting my career, right, there was already this war between following standards or following like Spring Hibernate path, right, which is like open source. And back then, to me, like seems following the open source way is much better, because again, the community thrive on it. There are many new inventions, and definitely we don't want to get associated with heavyweight kind of server and all that. Nobody likes that. So I think now that the specifications kind of like get evolved and modernized as well, I think I can see a lot of so many cool things happening in Java world. So again, thank you for that. So one thing these days when people hear about Java EE, right, like for me, right, it's kind of like renamed to Jakarta EE. So it's a bit trivia. What is the story behind it and why Jakarta? Because I'm Indonesian. In one sense, I'm very proud about it. Java and then now Jakarta. So maybe a little bit trivia. Why is this renaming?
Yeah, okay. So first of all, I hate it. I actually was not involved I was away doing other things, salon and stuff, when most of that was going on. Max Anderson is the person from our side who I think has the most visibility to what went on. So there was a lot of pressure on Oracle after Oracle acquired Sun to make Java open source and to make, and I believe, no, let me not say something on video where I might have my facts wrong. Anyway, there was pressure for various reasons, which, as I said, I'm not an expert on, to make the Java EE platform, open source and let it evolve out in the community. Now, so the Eclipse Foundation at the time was quite popular, and so they identified somehow that Eclipse was the right place to carry it forward. And look, I've heard some stories, but I wasn't there, so I'm not gonna count them. That was so Spanish. That was Spanish English. I'm not gonna recount them, but essentially, Oracle agreed to do that, but they insisted that the name Java, which they, acquired from Sun, couldn't be put on this stuff anymore, which caused this, renaming of all the packages from Java X to Jakarta. I actually have often asked myself, because Jakarta was a name for the Apache Jakarta project, and so somehow that name was transferred to Eclipse, and I have no idea how that happened. As I said, I wasn't there. Yeah, so now it's no longer called Java EE, which I'm really not happy about. It makes it seem, somehow less, than what it was. But it is still what it was, and really, I still think it is the best place for us to move the enterprise, technologies forward, and that's why, investing time in it.
Right. At least it still retains the J, right? So you can still call
exactly,
JPA
right?
and all that. Otherwise,
I presume that is where the word Jakarta.
Right.
Yeah, well, Jakarta is a city in Java, so.
So you now are working with, Jakarta data, Jakarta QL and all that, right? So as part of, solving the persistence problem, right? So maybe let's elaborate a little bit, right? So persistence, right? What do you think is some of the common problems before these Jakarta projects come in, right? So what are the common problems? What are common complaints from people? And what are you trying to solve now with this new standard?
Okay, so specifically with Jakarta data or with Jakarta, let's just talk about the whole thing, right? Because in a sense, we have a bunch of moving parts, and it's, sometimes difficult even for my colleagues to see how all the bits relate. Hibernate 6 was a massive investment of work and a massive step forward for Hibernate on the implementation side. We've had Jakarta Persistence 3.2, which has a bunch of sort of little improvements that you might almost think are not that significant, but together, I really do believe that sometimes, if you pile up enough little improvements, it amounts to a big improvement. After that, Jakarta Persistence 4 is a much bigger thing that's still working on. We've introduced Jakarta data, and that's forcing into the direction of this Jakarta query initiative. What is all this amounting to? Okay, so first of all, after so many years, we realized, okay, there were some things which weren't quite perfect, all right? Let's first of all say, what are the things that, the first step was, what are all the things that both TopLink and Hibernate have that were never in the spec? And let's just, that's low-hanging fruit. Let's just, write them down. A second thing was, especially since I had been spending a decade or whatever thinking about type systems, about type safety, and, I come back and look at this stuff and it's, kind of a little cringeworthy to see strings. Some places where there shouldn't be strings. So a big motivating factor was to improve the type safety of things, and that was what really, that desire for type safety and for compile time checking of queries and stuff like that was what convinced us to get involved in Jakarta data. I said last night, it was something that we were originally kind of not that excited about. But when we kind of realized that, okay, with annotation processes and with there was some non-trivial work to kind of get the Hibernate query compiler working inside an annotation processor, right, in a high performance way, right, so that, you weren't going to be sitting there waiting for for the compiler, was non-trivially hard, right, and involved significant hackage, but it worked. It works surprisingly well. I'm actually amazed at shocked how well it works. It actually works. And so it was when, kind of Steve and I realized that, hey, we can do this with an annotation processor and we can get something out of this which we really didn't have before, that we realized, okay, so maybe this repositories thing has something that's useful in it. And so we kind of, try to push this back in a different direction with this as the goal. And so finally, Jakarta data kind of delivers on something which I think Jakarta Persistence somehow failed in the end to deliver, which was, that compile time safe querying. And that's great, that's wonderful. Maybe Jakarta data might not be for everybody, and that's fine. That's completely fine. Jakarta Persistence doesn't need to be for everybody, and that's also completely fine. Yeah, so with Jakarta query, an aspect of Jakarta data, which I'm not the person to talk about, is that it does not only target relational databases, but can also be used with other different kinds of data store technology, graph databases, document databases. And we subsetted the query language of Jakarta Persistence in a way that allowed implementation of the subset or Jakarta data query language, on these other data stores. That process involved quite a lot of back and forth between the two specs. Okay, back and forth between them. It's like, me talking to Lucas, me talking to Octavio and Nathan. But that's still back and forth, and you realize, okay, no, this isn't the way. What we really need is a common specification document for Jakarta persistence query language, Jakarta data query language. So let's have a Jakarta query language. This will be the object-oriented dialect of SQL, right? There used to be one. The ODMG used to have this thing called object query language. It never went really anywhere. I don't think it was ever fully implemented. I believe maybe one or two object database vendors maybe partially implemented, but it was never fully implemented. But I'm sure its capabilities were nothing like the capabilities of, say, Hibernate query language, for example. So, hey, this is an actual thing. Like a dialect of SQL for querying, objects, classes, is an actual real thing. It would be good to have written down what that thing is and what it should be. Again, right? To have a public document that says this is what this technology should look like, what it should do. And yeah, it'll have a complete implementation of it, which we know to be implementable against relational data stores. Without giving too much away, I want to say that you guys should be looking forward to a world where the full power of Jakarta query, or Jakarta persistence query language, is available not only on relational data stores, but also on at least one other database technology, which a lot of people are using. But then but obviously, you can't implement all of HQL on a key value store or there are limitations. And so there is a subset which is meant to be implementable on less, let's say, data store technologies with less powerful querying capabilities, right? But I don't know how far this is going to go, but let's say that, document databases and graph databases these days have fairly powerful querying capabilities. So, perhaps we're looking, ideally, and I'm not saying this as a prediction, but as a hope, that maybe we can have an object-oriented query language that really does work against these very distinct technologies.
Right. You mentioned something about type safety, right? And I can imagine, let's say when I write a SQL query, right, it's a string, right? And then if somehow I get a typo or I misarrange the columns and all that, I could only get sense that I'm wrong when I test it or when I run some tests in the background, right? So why do you think type safety is so much importance in this persistence framework? And maybe if you look back at the language aspect as well, right? There are some languages that are type safe, and there are languages that are not, maybe more dynamics, and you can even change it during runtime and all that. So maybe in your view, what's the importance of type safety?
Right. So I think, one of the fallacies that I think a good number of people understand, but there are still some people who don't understand, is that a very tiny percentage of my time is spent authoring code. Incredibly tiny percentage. When I'm actually, developing rather than just thinking or writing, the most frustrating and demoralizing and by far the most time-consuming part of developing a, mature system like, Hibernate or like Salon or like, whatever you can think of, is waiting for the test to run. That is the most time-consuming part of developing, okay? So you want to run tests as little as possible, okay? People who make the claim, and you will hear this even today, but you certainly used to hear it 10 years ago, people who make the claim that I don't need types because I have tests are not taking into account that how often you run your tests is essentially, that is the bottleneck for being able to produce code quickly, right? That is the primary bottleneck, is how long it takes to run the test. Especially these days when, my test ran against H2 locally. Okay, great. Now I got to wait for them to run against, 10 different databases. Well, slightly less than 10 on, CI build, right? It slows you down incredibly. Okay, so any little thing which can be found at compile time without having to write the test makes me, means that I have to run the test one time less, and that makes me much faster, right? What happens with coding assistants once we throw them into the mix? Well, actually, nothing changes, right? Because coding assistants code like humans by nature, right? And they make the same kind of mistakes. And I don't think we can, at least not at current technology levels, I don't think we can assume that coding assistants are going to make fewer of the sort of bugs which can be detected by a static type system. And in fact, having used coding assistants a little bit recently, I've noticed that I spend a lot of time waiting for the. I mean, I want to shift things always to more code writing and thinking time and less finger twiddling and scrolling Twitter time, right?
Yeah.
So coding assistants aren't going to help with that part, but static types are going to help with coding assistants. And so, when we're talking about pushing development forward, I think that nowhere near enough attention. I still believe this, even after, the failure or whatever of Salon, I still believe that we are not paying enough attention to static typing and its potential. Java has a kind of medium level good type system. It's, has obvious problems, lack of type safety for null, generic type erasure, which is terrible, results in all these unchecked typecasts, which can fail at runtime in your tests. But it's still better and more expressive than, Python or Go or whatever, or whatever. I use Python on a pretty regular basis these days. I use Python for anything to do with quantum, I use Python for anything to do with AI. And it's miserable, right? It is so much slower. Oh my God, right? Like, things I can do with this in IntelliJ in Java. No, I mean, you're sitting there typing, pressing keys. It's that, man. It's terrible. And it actually doesn't have to be like that. Well, the reason, the biggest reason it's, okay, let's not say it's the biggest reason. Our reason I have to go to Python to do quantum things, to do data science, is that, unfortunately, we have no linear algebra library in Java. That's something that I really think our community needs to, jump on and say, Java could be I don't know if Java can be a good language for data science, but it could certainly be a perfectly good language for the kind of, AI applications we're seeing become, huge today. No reason it can't be, there's no reason, from the nature of the language why you couldn't have a version of Qiskit in Java. Well, there is a reason, which is that there's no equivalent of NumPy, right? Anyway, sorry. That was a.
I think essentially the type safety brings a much faster feedback loop, right? So even when you're typing, if you use good IDs, it will tell you straight away, okay, this is probably not right? And you can even use their kind of like auto-suggestion and things like that to fix it straight away, right? So I think the feedback loop.
I mean, it's important to always keep in mind, it's a balance, right? It's yes, it is true that a lot of typing errors are false positives. There's no doubt about that, okay? That is absolutely true. And I think that's where your first encounter with Java, not so much with Java, but certainly with a language with a very powerful static type system. But sometimes people first encounter with static typing, if they're used to it or something more like JavaScript or Python or whatever, is, but that's fine. That code's fine. Why is it making me jump through hoops? Okay. Right. And that's fair when your program is little, right? But as your program gets bigger and bigger and bigger, yes, you have to sometimes jump through hoops to accommodate, to get past these false positives. But ultimately, once the program gets big enough that you can't fit it all in your head, the benefits far outweigh the downsides. The other thing about false positives is that they often point to a lack of expressivity in the type system, and that often with a more powerful type system, you will have maybe less false positives.
Fair enough. Well, type safety is one thing that you are working on to improve, right? The other thing, I think I must guess that it relates to some of the maybe reasons why people hate ORM. There are two sides in the programming world these days, right? There are people who feel ORM is very useful and great. There are some people who may have been bitten by some past experience, say that ORM is the worst thing that they have used in the past. So I guess maybe you can explain a little bit why there are such love and hate relationship, and what are you trying to fix in this new spec?
So I mean, I'm not sure if I can give you a great explanation. It's something that I, have spent time trying to think about and trying to understand what it is that people are saying when they say they hate ORM. And unfortunately, a very unfortunate fact is that very often they don't actually give a proper explanation of what it is. And so I'm often left a little confused, and sometimes when there is some sort of an explanation, it's not a particularly good one. But I have some speculation. First of all, I think there's some aspect to it which is just that any persistent solution, and certainly a powerful object relational mapper like Hibernate, is a very complex piece of technology. Anytime you insert something complicated into your program, there's some sort of a cost to that, okay? Without a doubt. I think in addition to that, in the past, things like Hibernate picked a way of doing things which involved more magic than some people probably wanted, right? And so this comes back to this thing I've talked about quite a lot with the fact that, and this was, let's be clear, this is what most people ask for, right? This notion of a stateful persistence context of managed entities, so these objects that represent the state in our database, belong to a first level cache. They're automatically dirty checked. So if I change them, the change to them is automatically propagated back to the database. Everything happens sort of asynchronously. So me calling the persist method doesn't actually do very much. And that programming model is obviously more difficult to reason about. I don't think there's any denying that. And it's certainly more difficult to debug. And so I speculate that this is a major factor in people who dislike ORM. I don't think that what they dislike is the object relational mapping bit. I think the bit that they dislike is the stateful persistence context bit. And here we come to what I think may have been one of my worst mistakes in my career, which was that in Hibernate 3, we kind of recognized that there were cases where stateful persistence contexts simply weren't appropriate, and so I quickly did this thing called stateless session that was sort of obviously an incomplete state, threw it out there, and then I went to work on other things for 15 years. And because it wasn't in JPA, because in our documentation we kind of, presented it as this thing for bulk processing, which is another sweet spot of ORM anyway, right? People just didn't use it, right? And it wasn't finished. And because nobody's using it, nobody thought to finish it. And because it wasn't finished, nobody felt like this was a viable alternative, right? And when I kind of came back to persistence, I looked at all this and I tried to, trying to think about, well, okay, even though this is clearly, empirically, this is clearly the thing that most people are using, right? Why is it that we have this minority of people who dislike it? And one of the things that really hit me is, well, they probably don't like the stateful persistence context programming model. And so that was a mistake. We should have had the stateless model in JPA from the start. Anyway, so it's going to be Jakarta persistence 4, 2 decades too late. And, you have me to blame for that. I shudder to think at how many billions of dollars or something of lost productivity result from that one error. Forgive me, So that was a mistake that we're belatedly fixing. Stateless session is now fixed, and Jakarta data by default, in our implementation will go through a stateless session, and so hopefully people now, those people who, now have an alternative, which is less magic, which they have more control over. Another thing is, I think that Hibernate, at least, if you see people complaining about Hibernate, at least in the case of Hibernate, I think that it was originally developed with a view of what was good error reporting that was actually relatively okay back in 2003 or whatever. when things typically didn't have great error reporting, but that kind of got stuck a bit there. And one of the things we put a lot of work into recently is improving all the error messages you get out so that people aren't left, and I'd hate it too, right? When I'm trying to use something and I do something wrong, but it spits out some message that doesn't identify what it is I did wrong. And I think that Hibernate used to be quite bad at that. It wasn't, certainly I've seen much worse things, but it used to be quite bad at that. So that's another thing I think where we really went wrong, and that probably was a major contributor to people who are hostile to object relational mappers. I'm sure that we weren't the only object relational mapper who had poor error reporting, because good error reporting is actually really, really hard, especially with when you have this. One of the problems we do have to deal with is that the databases themselves and the GVC drivers tend to report errors in an atrocious way. And so then we have to figure out how to make sense of it. But we traditionally did a bad job on that. We do a much better job on that now. So those are two things.
And I think I like the way you explain it, right? Because in the very beginning, when people pick up Hibernate or maybe learn about it, the magic thing really stood out. Like, whoa, what do you mean? Like, it can flush all these things automatically. You can just make changes to the object. It knows how, to update the database and all that. But obviously, when you start building enterprise applications, when many developers are working on it, it's really hard to debug, especially when things happen asynchronously, right? And maybe that's some of the reasons why people hate it. The other one is probably about association, I suppose, like eager fetching, lazy fetching, when you have one too many, many too many, those kind of stuff.
Yes. Yeah, but I insist that this problem is fundamental, okay? That this problem you will have to deal with even if you're writing your stuff by hand. Okay, look at the way I tried to present it last night, okay? You have two options. Not really, because you can actually choose. There's a linear space of options in between. There are two extreme options, right? One of the extremes is, I don't need entity classes, right? I'm gonna have queries I write in SQL or whatever. It doesn't have to be in SQL, right? In JPQL, no problem. And I'm gonna have these little records, right? Which model the shape of the result set of the query, right?
Yeah.
This is actually reasonable, especially on a smaller program. Excuse me, if you have just a few screens. This is entirely reasonable. It works. You write a query which fetches exactly the data you need, and then you have something which will slop it into a list of records, okay? And thousands of things will do that for you. Yes, you can use Hibernate to do it for you, but you can also use much simpler things as well. Right? So that is an option. Now, I'm never going to tell you it's a terrible option. I'm never going to tell you it's a bad option in context. What I am going to say is that I don't believe it's the best option in all contexts. And I think that the fact that by far the overwhelming majority of enterprise developers are not choosing that option is a very strong hint that, in fact, in most contexts, it's not the better of the two options. Okay. So the other extreme is that you have Java classes which represent the entities, the basic things in your model of the problem domain. Yeah. And the thing and the fundamental constructs you work with in the business logic in your program are graphs, not trees, excuse me, graphs of, not even DAGs, but serious graphs of entity instances. And it doesn't matter whether you use ORM or not, you're gonna have to deal with the following simple fact. In a relational database, this is probably not the case for a document database, that's murkier, right? But in a relational database, you do not have trees. Everything is interconnected. It's a fully connected graph, or a graph with, a small number of connected subgraphs, typically, okay? You cannot just go, give me the book and everything that's related to it. No, because everything that's related includes all the authors and all the other books they've written and all the authors of all those books, and pretty soon it's the whole database, okay? And its publisher, and all the other books are published by that publisher, and it's the whole database. So you have to determine where to stop that graph, right? This didn't arrive in the first extreme option because we kind of had a different type-safe model for each query, right? But over here, where we're trying to share the same model between all our bits of business logic, this problem arises, because of how shared that entity model is. we can't, into the type system, engineer the fact of where the graph stops. And so there's this fundamental hole in how this is typed. That hole is plugged by lazy initialization exception. Okay. And so what happens, right? If I approach this naively, what happens? I run into one of two things. I run into, lazy fetching happening when I didn't want it to be happening, and n+1 selects. I run into, lazy initialization exception. Why didn't they set fetch? But, okay. There's a solution, and the solution involves discipline, all right? And I insist to you that this is not anything to do with using an object relational mapper. It is a fundamental aspect of using graphs of entities to represent your data and having a database that's external to that. You have to specify upfront what data you're going to use in this transaction, have that data fetched in an efficient fashion, and that is certainly no easier if you write that code yourself in SQL. In fact, it is harder. Hibernate makes that much, much easier, and this is where people what they get wrong, right? But you have to do it. You have to specify explicitly, right? What happened? People have been sold, not by us, okay? We have always said right from the start there is no such thing as transparent persistence. People have been sold in some books this notion that persistence can be transparent. There's this stuff that yeah, what's it called? Ports and adapters or some nonsense. That we can have persistence is I don't know, an adapter or something, right? And we can just swap it in and out, right? No, you cannot just swap persistence in and out, right? It fundamentally impacts the whole way you define the behavior application. You have to specify, I'm going to be needing this data, right? Get me this data in an efficient way, and then I can start navigating my graph of objects and if I run into lazy initialization exception, that's my indication that I need to get more data. Before I start writing n+1 selects. Interestingly, the stateless model, where lazy fetching is an explicit operation rather than an implicit operation, because this thing is never a managed entity, results in more lazy initialization exceptions, and that's an advantage. Right? Because it's telling you, you didn't have the data you maybe thought you had, right? And so you're far less likely to accidentally get n+1 selects happening. I hope I explained that well.
Definitely. I think it's, again, the discipline that you mentioned, right, for developers, right, especially when accessing data. I mean, many developers just think, okay, I can just query, do whatever I need, and just pass it back to whatever that needs it, right? But I think thinking about transaction boundaries, that's the first thing that can be difficult, right? You want it to be short as much as possible. And then second thing is fetch as efficient as possible. And this could relate to the type of database that you use, right? It could be relational, right? It could be document database. Different database has different characteristics when you query them.
It relates to also how you can, if you introduce a second level cache into your system, that's also going to impact how you fetch it.
And cache is always like the most difficult problem in computer science, I guess. Yeah. So definitely, thanks for sharing that. And I believe these days, right, there's also a way for you to mix and match, right? So, like what you mentioned, the two extreme, right?
Yeah, right.
Mm-hmm. So for some problems, maybe you can use ORM, which is much more effective and efficient, especially when you have so many columns. I don't think we want to write it, although now maybe coding assistants can help in a sense. But in some way, when you actually need to kind of like in detail specify the queries, you can use the stateless option or maybe the records result set kind of types to actually represent that.
Yeah, so I think, as I said, so I think that there's these two extreme options where, no, I'm going to use this everywhere, and no, I'm going to use this other thing everywhere. No, I think the best option is to use the thing that's most convenient in this particular context and which gets you where you want to go fastest. And certainly, any decent ORM solution will make it very easy to use either of those options.
Right. So maybe if you can share a little bit these exciting things that you are building in this new specification that people can expect, right? Because when I watched you last night, I'm excited myself to see, wow, there are so many cool things that I can do, especially the repository and the fine annotations and all that. I find it quite exciting, actually. I wish I could probably have some chance to work on Java again, but maybe...
What are you writing with?
I'm currently using TypeScript more.
Sorry, you said that. Yeah.
So maybe tell us some glimpse, maybe like a marketing pitch, why people should consider this new Jakarta repository data and queue.
So... Right. So I guess the fundamental thing is I'm never going to tell you you have to use this, or you have to use this. I'm going to say, try this out and see if it fits your flow. So Jakarta data, at least in our implementation, the primary advantage that it offers is the ability to immediately get that feedback of, oh, my query is correct or my query is wrong. As soon as you're altering your code, you just press, command / IntelliJ, sends it off to the annotation processor, and the annotation processor will give you meaningful error messages back. That's, to my mind, the primary reason to use this. Of course, there are other people who have other reasons for liking repositories. Some of those reasons are good reasons. Some of the reasons I find unconvincing. But one reason, which I think is, sounds kind of silly, but actually I think it's a good reason, is it gives you a place to put your queries, right? I don't think there's anything wrong with writing queries directly in the, controller or whatever. Nothing wrong with it. Again, it depends on what complexity it comes back, But I see the desire to have your queries in some persistence place, right? Mm-hmm. And so I think repositories are a reasonable way to think about organizing your queries, right? I think that the pre-existing approaches to repositories fail to deliver in this respect because they have the notion that there is a one-to-one association between repositories and entity types. And I think that's actually incorrect. I would go, if I want to take an extreme position on this, I would say, why not have a repository per controller, right? And so, if you have that's likely to be a construct with a higher cohesion, right? Yeah. Of course, I'm not advocating that that's what you should, literally, that's what you should do. No, you should think about where do I want to organize my stuff. So repositories give you, or at least in Jakarta data, give you a flexible way to organize your code that I think is appealing, with this type safety, which I think is a major selling feature, is a real step change to how productive you can be using JPA or whatever, right? Secondly, another new thing that we're working, it's not there yet, okay, I'm talking about Jakarta Data 1.1 now, is this issue of dynamic programmatically constructed queries. Mm-hmm. So in the very early days of Hibernate, there was this thing we had, a criteria API, where you could kind of build a tree of restrictions on an entity, and it's, and I guess you know what I mean by a tree-like query, right? It's, we don't have kind of restrictions which involve, two leaves of the tree. And it wasn't type safe, it was all strings, and it was kind of janky. That's a word my daughter taught me. And we kind of have left that in the past. In fact, it doesn't even exist in Hibernate 6. Now, there were actually, at some point I noticed, when we took it away from people, we noticed that there were people who actually really liked it and complained that this totally rubbish thing, that from 2000 and, whatever, that there were people who were still using it and actually found it to be the most convenient thing. What happened in JPA too, people wanted to have like a criteria API, which was a full model of everything you could do in JPQL. Mm. And they also wanted to be able to have multiple implementations so that each vendor could have its own implementation of the criteria API. And then I came along and I wanted to be type safe. And so we got this monstrous API that it's, at some point for 10 years, I would look back at this and go, wow, I really associated myself with that. Now, funny thing is that during those years, support for annotation processes got better. Java introduced the var keyword. We found a bunch of other things we could do with static meta model, and now I'm actually super happy that we did that. And in fact, the criteria API isn't as bad as it used to be. And also, people just got more used to working with generics, and the whole thing is less embarrassing, much less embarrassing now than I felt about it for years and years and years. But it's still nobody's favorite API, I think is fair to say. It's quite verbose. It's quite good for bytecoding, interestingly. Yeah, the code assistants seem to do a good job with it. But it's not great. So we had this, so I think for years and years and years, we've had this hole between, JPQL for static queries, the criteria API, which is the whole hog of being able to completely, entirely construct everything about the query completely dynamically and programmatically. And yet, I think that what most people actually wanted was something in between those two extremes again, right? Jesus, it's a very recurring theme here. Which was that they wanted to be able to, they had some search screen and they wanted to be able to programmatically add this a restriction on this field, a restriction on this field, and no restriction on this other field, right? Yeah. So in JPA 1.1, we have, rectified what I think, that historical mistake, I think, and we're in the process of introducing an API, which is, in some sense you could view as a rethinking of the original API in old Hibernate for tree-like restrictions. I think it's actually super elegant. I don't know what other people are going to think. It's, again, these APIs for internal DSLs, right? No, wait. I always forget which one's external, which one. Internal DSL, right? Are naturally complicated, especially if you want type safety. But I think it's elegant. I think it's nice. I think it's easy to use. And so I think that is going to be a step forward in terms of solving something that traditionally was left, unsolved.
Right. Thanks for sharing some of these. I'm not sure how people can follow without even trying, right? Or seeing your demo, right? So definitely, I personally, again, I shared my experience when I saw your talk. I'm very excited, even though I'm not a Java developer anymore. I feel excited. And I'm sure so many other Java developers out there who saw it will find it very exciting and useful as well. I think the feedback loop is really, really good, right? So I think hopefully the project turns successful. I can see throughout the way you explain stuff, you are, even though you try your best not to say that there's a best architecture, but you tend to intentionally think about architecture. And there's a context specific to some people, right, that people need to understand before they pick a certain architecture. So maybe if you can think or maybe explain to us, like, how do you actually explain an architecture so that people know what's the best thing to adopt for their context? Because, these days so many people talk about architecture wars, right? Okay, I have microservice versus monolith. I have DDD versus I don't know what else, right? I have, Spring Framework type versus, all the others. So maybe how Gavin actually thinks about architecture. Maybe if you can give us, some advice here.
Yeah, so first of all, to begin with, I had long had a policy of attempting to avoid giving any advice on architecture because, number one, I don't write application programs and I haven't written an application program since I was 20-something. And so whatever advice I could possibly give is almost certain to be wrong, right? And I think, generally that our whole team had that view that, we were better off providing a library with powerful primitives. Even if you look at something, you could say, look at CDI and say, okay, CDI was this thing that is more of a framework, or if you look at the whole platform and say it was more of a framework, okay. But, I always wanted to be a very flexible framework that, in fact, one of the goals of CDI was to not force you into this layering that existed, and to give you the flexibility to introduce that sort of layering if you wanted to, but not if you didn't wish to. My goal has always been to give people powerful primitives so that they can implement whatever sorts of architectural decisions they wish to implement, okay? Unfortunately, if you kind of withdraw from that space of giving people advice, what happens is that, into that vacuum pours a deluge of people who have lots of opinions, right? And I think I sort of see, sometimes that people have been, made to feel that they have to do something in such and such a way where the basis for the idea that they have to do it that way is just not there, right? There is no math, but the whole discourse around design patterns and architectural patterns lacks foundation in logic and math. It lacks empirical foundation. Yeah, okay, this worked great for you on your 2 projects, but there is nobody out. I think what people need to understand is that these so-called experts, there is nobody out there who has spent 10 years developing and maintaining more than 2 or 3 projects, all right? There is nobody like that. Why? Because people aren't that old. So either they've skipped from project to project to project and never had to deal with any of the consequences of their decisions, or they've really only worked on 2 projects. And so when you hear people making that sort of advice, you need to understand that that worked for them in the context of the 2 projects they worked on, or maybe they never actually even had to maintain a system with this with these decisions, and in which case I really, I'm sorry, but I'm going to treat their advice with a great deal of skepticism. Okay. So what do I say instead? If you can't trust the advice of architecture experts, what should you do instead, right? Because obviously you have to have some basis for making decisions, right? Yeah. And so what my advice is, and it's always been my advice, I think, it's always been my position, but it is more and more my position recently. I've been radicalized on this lately from seeing this discourse around DDD. My now radicalized position on this is that architecture is something that has to emerge naturally from the code, right? The code should be pushing you in a particular direction. If it's not, then you need to have a different relationship with your code, right? A relationship which is based on being very critical of it, right? It's kind of obsessively trying to make it beautiful, obsessively applying the first commandment of software engineering. Don't repeat yourself, right? Oh God, I see lately a particular, some type of meme on LinkedIn of people challenging dry and saying, "Oh, dry is rubbish. You can repeat yourself, and until you have like 3 instances, it's okay that you repeat yourself." No. Dry is fundamental. Dry software engineering is about dry. It is the most basic. It is the most basic principle, and as soon as you have 2 instances of the same code, you should refactor, right? Like, I'm sorry, I'm as soon as you have 2 instances, you have the problem, the possibility that you make a fix there and you forget to make it there. So the process of arriving at an architecture is a process of obsessively refactoring, iteratively, arriving at something that works naturally in your context. Now, yes, it does involve thinking about modularity. It does involve thinking about APIs. It does involve thinking about layering. Now, layering is this thing where, layers are easy to come up with when you draw boxes and sticks on whiteboards, right? Yeah. But layers come at a cost, right? I would never say never introduce layers. We certainly have layers within Hibernate, but layers should be, something that you introduce with care when you can see that they actually make things better at the code level. But everything has to be done. Architectures have to be motivated from the level of the code. If they don't make the code better and more elegant and more flexible, then you should not be doing them, right? And so somebody who comes in there with their massively cooked architecture and all these patterns and says, yes, you should be doing things this way, I'm sorry, but no, you shouldn't, unless you can show me that makes the code better. It makes it simpler, more elegant, more better factored. That is my view.
I guess the main point that you mentioned about architecture should emerge from your code base, right? And the kind of problems that you're dealing with, that's the first thing. And iteratively refactoring it. I think maybe this part is kind of like what people don't aspire to do for some sense.
Yeah. So here's the thing. I guess the counterpoint to everything I've just said, and I guess the best argument against it, right, which is always what you should try to do if you're going to start ranting on a podcast about your dumb opinions on something, right? Then you should ask, what's the best argument against this? And I think the best, you've exactly identified what's the best argument against it. The best argument against it is, I didn't have time for all that refactoring. I'm just trying to solve this JIRA issue, right? So what do I think? I think issue report-driven development is a major problem for many types of projects. Certainly for the kind of projects which we have, if everything we do is responsive to a complaint from a user, what happens? You get a product whose semantics have all sorts of special cases, right? For a product like Hibernate, that is death, okay? Like, that produces a product which cannot be reasoned about for anybody. Why? Because it has all these little hand-engineered in special cases for that guy over there wanted to work like this, that guy over there wanted to work like this, and now I can't reason about what is the correct behavior, right? Yeah. This is Far worse, obviously, if you don't have a spec. If you have at least a spec, right, okay, well, what does the spec say we should do, and what can we infer from what the spec says about what should happen in this case, even if it's not explicit? And so to me, yes, it's important to solve issues, issue reports, obviously. Okay, it's very important. But we should never approach an issue report assuming that what this user is asking for is something we should do, right? And I piss off a lot of users, right? Because I'll be like, no, we're not going to do that. It's not that I don't see why you want me to do that, right? I do see it, right? I absolutely see why this is what you need. But from, I don't want to say high level, but from the broader perspective of where does this take the semantics of this whole system, we're not going to do that. And on the side of, I don't like people spending time doing grandiose refactorings that, introduce some, again, box and sticks on whiteboard. Oh, we're going to do this because I like it, right? No, don't do it that way. But what I do really like is sitting there, spending some time looking at this code and spending some time and trying to improve the code, right? And out of that should emerge, if you do it well, an architecture or layers or at least, elegant ways of reusing functionality and semantics which are consistent across different, parts of the product.
Yeah. And I like the keyword that you mentioned, systems that people could reason about, right? Don't forget you work with multiple developers. If you don't have one uniform way of doing stuff, I guess it's pretty difficult to reason and evolve the system, make code change, even bug fixing, right? Sometimes it can be very, very difficult. So you mentioned a little bit about DDD. I don't know whether we should go there, but
I've made it my punching bag or something recently. But look, I'm not going to put myself forward as some expert on DDD and whether it works or not. I have no idea. Maybe it works for some people. I'm sure it does. Some people seem to like it. Okay. What I don't want is for the assumptions behind DDD to find their way into technology that we're using, right? And that has begun to happen in some areas. So we see a framework, which will remain nameless, which is advocating that things have to use aggregates and admits in the documentation that this is to some extent, it wasn't unnatural, wasn't the word they picked, it was not untraditional, and traditionally not considered the normal way to work with a relational database. I can't think of that quote off the top of my head. That's massive red flag, alarm bells going off as soon as I see that. Okay, as soon as somebody says that our framework has the expectation that you're going to work with your relational database in a weird way. Okay, no, we want to work with relational databases in a traditional, normal, natural way. And so to the extent that DDD advocates this idea of aggregates, and one of the problems in talking about all this stuff is that none of these things come with particularly robust or rigorous definitions. Okay, and so if you read the definition of aggregate, I'm not even sure that any two people agree on what it means. And you read it and you try, with the perspective, okay, look, let's, be as charitable as possible and let's try to assign to these words the most charitable, meaning to them. Been through that exercise, what most charitably could it possibly mean? Even then, I cannot escape to the conclusion that they think that relational databases should be document databases, okay? That the data exists as a discrete set of trees, and the process of retrieving data is a process of retrieving the root of the tree and then working through the data from that root. This is neither a natural nor is it a correct way to work with relational data. Relational data is not made of trees. That is a document database. And if someone can't distinguish between what is a document database and what is a relational database, then please be very careful about taking their advice on data. And so, that's been a little bit of a jihad I've been running recently against, telling people, no, look, aggregates probably don't make sense. Yes, I'm not saying it's impossible that you could find an aggregate. You could find a tree somewhere in your data model. Yeah, I'm sure you can, right? But don't try to shoehorn everything into this, okay? Don't try to shoehorn things into aggregates. That usually doesn't make sense.
Yeah, I mean, let's not put a doctrine that you have to follow this 100%, right? Always, I think in any kind of architecture, there will be the plus points plus the negative points. It's all about trade-offs at the end of the day, right? So I think picking the right architecture for your context that you can reason about probably is like
the most thing that people should aspire to work on, right?
Like trusting, in some sense, that whole rant was trusting your own intuitions about what's going to work for your system, right? Like people, trust that it's okay. When I was, how old was I? 26, 28, I told my very experienced manager, no, we shouldn't do entity beans, okay? Even though IBM and Sun and everybody were telling the whole world they should use entity beans, right? No, you can be right and everyone can be wrong. Like, this is the thing that happens, right? As long as you have as long as you do understand your own system and what your system does, and you should do the thing that seems natural and works.
Yeah, I think that's very inspiring, definitely. And look what it had led you, to creating Hibernate, working on specifications and all that. I think, again, we as a community can thank you for your contributions. Gavin, I think it's been a great conversation so far. I think many people would have learned a lot from listening to this conversation. Unfortunately, we have to wrap up. Before I let you go, I have one tradition in my podcast to actually ask this question. I call the 3 technical leadership wisdom. You can think of it like an advice that you want to give to listeners. Maybe if you can pick the top 3 version of your...
nervous. All of these things. Yeah, go on. Shoot.
Yeah, so maybe if you can share, that would be great.
All right, so there's one thing I've been on about recently. I think I've recently seen a lot of it over the last years. I've seen a lot of advice that would tend to instruct people that they should be more agreeable. And that people who are disagreeable and opinionated and prepared to fight for what they believe with are so-called quote-unquote toxic people. Now, in my opinion, as soon as you see someone describing someone else as toxic, then you should be asking the question of who is truly the toxic person here. No. Right. People have different personalities. There are people, disagreeableness. Agreeableness is one of the big 5 personality traits. Okay. Yeah. There are people who are more comfortable. It's not about being insulting, but there are people who are more comfortable with disagreement, and there are people less comfortable with disagreement. When somebody who is a person who is comfortable with disagreement disagrees with you, they're not attacking you personally. They are most likely trying to find a way to the best, a technically good solution, right? The road to consensus passes through disagreement as a necessary waypoint. We cannot possibly arrive at a consensus if we don't all express forthrightly, honestly, and with the necessary force to, our opinion, and not necessarily even just our opinion, but the issues that we're concerned about that the solution has to satisfy. And we have to pass through that point of disagreement to arrive at consensus. Otherwise, we're not achieving a consensus. What we are achieving is an end state where 9 out of the 10 people have shut up. And so I think we need to come back a bit from this question of some people are toxic because they have opinions and start looking at it as how can we facilitate, how can we work to facilitate these kind of discussions so that people who are less comfortable with disagreement can also feel safety to put forward their views and it's not just someone bullying the others, right? But but that also that we're actually having these discussions and we're not just telling young developers they need to shut up and do what their boss or whoever is telling them to do. I think that is the risk with this kind of talk. I see a lot on LinkedIn. I think the risk is that you're giving people the idea that they should shut up and go along with the flow, right? And so, in my opinion, that is probably not great career advice, ultimately. Your best career advice is to learn how to put your disagreements forward in a way which generates the least possible emotion, with understanding that there will be emotion in it, right? Emotion is a natural part of this process. So I don't know. That's something which you can take it or leave it. That's just some opinion I have of it all. I'm not saying I'm an expert at any of this.
Right. Thank you so much, Gavin. It's a pleasure to meet you, listen to your talk, and had a chance to actually talk to you in person for this episode. Again, thank you so much, and I hope you enjoyed this conversation.
I did. Thank you very much, Henry, for having me on it.